Hello everyone. Just checking. How can I switch slides? Okay, thank you. So I'm Mathieu Lachat. I'm here on the behalf of ARIA Technology, which is a French partner of ARIANET, and I will have a less technical presentation than those we have seen until now, because I will be presenting a project we have conducted on a Mexican city of Guadalajara, which was combining several models and modules that were presented today that are developed at ARIA or ARIANET or in other institutions. And in this case, we combine modeling and monitoring tools to create a forecasting system for the city of Guadalajara. So to present quickly the partners that were involved in the project, we will have ARIA Technologies and ARIANET, but also French partners that were involved on the monitoring part of the project. We had the French Republic that was partly funding the project, and we had our local partners that were the University of Guadalajara and the CADs that were very important in establishing emission inventories there. So we had to construct a local inventory emission. I will present from how we went to global scale emission inventory to a more local emission inventory, crucial to have forecasting at neighborhood street scales. Of course, we combine several meteorological and modeling tools to go from a regional scale to an urban scale, and we had then to provide interesting API for end-user application and other tools like the emission scenarios that was actually developed by ARIANET. I will present some results quickly. And a health module that was developed by our partners in Brazil. So the area of study, to show it quickly, as I think not everyone is familiar with the country of Mexico. We were mostly focusing on the state of Jalisco, in which we will find the city of Guadalajara. The state itself contains a population of a bit more than 8 million people. And so we had to go from a coarse resolution with a regional domain to a very small area that will be centered on two neighborhoods of Centro and Miravalle. So to do that, we combined several modeling tools together, going from the WRF meteorological model using the shimmer chemistry transport for the three coarser domain, going to 27, 9, and 3 kilometers of resolution. And then we used the ARIANET and ARIA Swift and Farm model to represent the fourth domain here that was about 1 kilometer of resolution. Then for the first time we have worked with a French model that is developed in the University of Lyon, which is the S.R.L model that allows us to have a modeling to a street resolution. And finally, this pre-model was used to have a very high resolution modeling over two domains that are Centro and Miravalle that are interesting because one will be a residential neighborhood and the second one, Miravalle, will be more of an industrial neighborhood. So here a quick overview of the result. As I said, it's less technical than in the previous presentation, so I will not go into further detail of the model, but if you have some question on the shimmer chemistry transport model, I'll be glad to answer that. For the farm model, it has been talked a lot already, but if you have any question, we will go through it too. So we can see that we went to a large resolution, and we can also say that we use as boundary condition the CAMS forecast product that was also seen a bit earlier this morning. So really this project was about combining many different tools to go from the large to the small resolution. Here is an overview of the S.R.L model. So this one is less known, so I will talk quickly about it. So it's not an Eulerian transport, it will be a Gaussian model, which allows us to have a very high resolution and to preserve calculation times that are reasonable. And we have to provide a street network, and we will have this kind of results that you can see here that are that with a resolution slightly coarser than the spray model. So it was our first try with this model. We are still trying to understand how it works and how the results are. And here, a quick overview of the result we had for the spray model. So here we have an industrial neighborhood. So it was interesting, and here we had to work a lot with our partners there that had the local knowledge of the city to understand and fix the problem we had in our emission inventories that I will now present in the next slide. And here a quick overview of the captors that were installed during the project, and yet it's still an ongoing work, but it will enable data assimilation for the model outputs. So we had to produce a local emission inventory, so combining the various information we gathered from our local partners there and using the tools that are developed at ARIA and ARIANET, such as the traffic module, to have a great representation of the traffic network. And we can see here quickly how we have a distribution of our emission inventories. So we will find several kind of activities, and this work was conducted really hand-to-hand with our partners in Guadalajara. So here I want to display quickly some results we have had. So for the coarser domain, we used the EDGAR global inventory emission, which is resolved to 1/10 of a degree. So this scale will obviously not be adapted when we go to a higher resolution. So we can see that already for the third domain that is here in the middle of the slide, that this resolution is already not completely appropriate. So we have on the right the result of the emission we have produced that will have a very higher resolution, and that will allow us to have trustable result with the farm and the spray domain. So I wanted to show a quick overview of that. So a very important part of the work we had to do to produce this new inventory emission to not use global inventory emission. And so following this work, we had to evaluate how the performances of the model. So we had several stations in the cities, but we mostly focused on two neighborhoods, the Centro and the Miravalle neighborhood, and we focused on 4 episodes. So it's a little difficult to read, but this phase of validation helps us to modify our inventory emission, because in the Miravalle section and in this neighborhood, we were not aware of some industrial activities, and so we had a gap between our result and the concentration pollution that were monitored by the station in the neighborhood. So talking about it with the partner in Guadalajara helped us to fix this issue, and we had better performances nowadays. So we can see mostly for Miravalle today we have better correspondences for the carbon monoxide, and we still have some work to do on the PM10 value, as we still underestimate the concentration. So this is with the farm model, so a slightly coarser resolution than with the spray model. So I would believe the resolution can explain partly the difference between what we observed and what we modeled. And something we have added to this project was the health module. So this module will combine various information that are socio-political information as the health service that you can find in the various neighborhoods of the state of Jalisco. And combining those various information with the concentration pollutant that is forecast every day, we can have an index of risk that is then displayed on the online application. And so I will talk briefly about the emission scenario. So this is also something that is provided online that will allow people to compute emission scenarios. So this is actually the same slide that Alessio showed in the opening of this talk, but it was part of this project. So you can see that online several scenarios have been tried, and you can see directly differences between the various outputs. And we also have a web demonstrator that is available, and it can be possible to see the result for the various models, so going from the quarter domain to the neighborhood of Centro and Miravalle, and also the various the main pollutants that are controlled in the Mexican legislation. Results for the health module are also available. And so this is kind of the end user part of this project. And this is the end of the presentation. Thank you everyone for your attention.